My name is Sergio Hernandez. Today is going to be Sunday, I believe, September 7th. This is the video portion of my anatomy physiology class, Biology 240. And today we're going to be talking a little bit about the respiration system and how to calculate tidal volume using a balloon. So let's get started. A few things we're going to need here. Your standard balloon. You need a tape measure with centimeters. And I just went ahead and put some of the calculations down here just so we can make this thing a little easier. So I already did all the math on this portion of it for my lab portion. So let's go ahead and start. The first thing we want to do here is you want to figure out how many breaths per minute you do. So in my lab portion, they want you to calculate and pretty much time yourself breathing for 30 seconds. So you would go ahead, sit, relax, and go ahead and breathe while you got your little stopwatch on. And you're going to multiply that times 2. When I went ahead this, you're going to do a series of 3, and then you're going to get the average of. My average came out to 18.66, I believe, breaths per minute over my overall 3 trials that I did. Once you do that, the next thing you want to go ahead and do is you want to figure out the average radius of your balloon with you basically holding your breath. So what you want to do is you want to get a balloon, stretch it out a few times, and then you're going to breathe into it. So you're going to take a normal breath. It's not a forced one. You just want to go ahead and breathe. It's a little harder because there is some resistance in the balloon where there wouldn't be when you're simply breathing. So you're just going to get a breath and you're going to fill it in, twist it a few times so you don't lose the air, and hold it. And you get your tape measure, and you're going to basically measure out. You want to use a tabletop or something and kind of smush it down a little bit. In this scenario, I got about 52 here, 52 centimeters on this one trial. And you would do that again in a series of 3 and get the average. My average for the 3 that I did for my lab came out to 53 centimeters. So to go ahead and get that radius, to calculate that, there's a formula. There's a couple formulas here, and this is why I made some notes. The formula is going to be, radius is going to equal the circumference of the balloon divided by 2 pi. Pi, I believe, is 3.141 and so on. So 2 pi comes out to 6.28. So by dividing, in this scenario, my circumference, my average was 53. We're going to divide that by 6.28, gave me a total of 8.44 centimeters. So that went ahead, and that's going to be my overall radius calculated down. The next thing we want to do is calculate the average of total volume. To do that, there's another little formula. This one's a little more tricky. And this is going to be 4 pi multiplied, so 4 times pi times the radius, but this time it's cubed, and all divided by 3. The 4 times pi is going to, I already figured that one, that's going to be 12.566 and so on. So by doing the formula again, 4 pi times radius cubed divided by 3, my total came out to 2,518.35, and that's going to be in milliliters. So that is the total volume of the balloon. The next thing we want to figure out is going to be your minute ventilation from this calculation. So to do that, there's again a third formula, and that's going to be total volume times your number of breaths per minute divided by 1,000. So all you do is use that, plug in the numbers, and that's going to be my 2,518.35 times my breaths per minute, which are 18.66. That's divided by 1,000. My total came out to 46.99, and that is liters per minute. So that's the way you would figure out the tidal volume and your minute ventilation using a balloon. So I think I went over this And I just want to say thank you very much.